The combined gas law. All three factors which affect gases, volume, temperature, and pressure, can be combined into one equation, the combined gas law. The combined gas law is P1V1 over T1 is equal to P2V2 over T2. Let's look at some combined gas law problems. Sample problem. Carbon dioxide occupies a 2.54 liter container at STP. Remember that STP is standard temperature and pressure. Standard temperature for a gas is 0 degrees Celsius, and standard pressure is 1 atmosphere. What will be the volume when the pressure is 150 kilopascals and 26 degrees Celsius? They're asking us what the volume will be, so that's going to be V2. And we're given the initial volume of 2.54 liters, standard temperature and pressure, so temperature is 273.15 Kelvin in terms of Kelvin, pressure is 1 atmosphere, and the P2 is going to be 150 kilopascals, and T2 is 26 degrees Celsius. We're going to have to do some conversions first. We need to convert Celsius to Kelvin. We do that by adding to it 273.15, and we get a temperature of 299.15 Kelvin. Also, we have pressures in two different units, atmosphere and kilopascal. It's easy to change atmosphere to kilopascal. You see in the conversion that 1 atmosphere is equal to 101.3 kilopascal. Now we can use the combined gas law. We want to solve for V2. To isolate it, we're going to multiply that side by T2 over P2, and we're going to have to do that the same way to the other side. P2 and T2 cancel out on the right-hand side, and our equation becomes V2 equals P1 V1 T2 over P2 T1. Plugging in our values, P1 is equal to 101.3 kilopascal, V1 is equal to 2.54 liters, and T2 is equal to 299.15 Kelvin, all over P2, which is 150 kilopascals, and T1, 273.15 Kelvin. All the units cancel out except for volume, and we're left with 1.9 liters. Another sample problem. The pressure of 8.40 liters of nitrogen gas is decreased to 1/2 its original pressure, and its temperature is doubled. What is the new volume? So the new volume is V2. We want to find that out, and we're given an initial volume of 8.40 liters. And that's it. We're not given any more numbers. We are told that the pressure is decreased to 1/2 of its original pressure. So let's call the original pressure P1. P1 is equal to P1. P2 is going to be equal to half of that. So P2 is equal to 1/2 P1. And they tell us that the temperature is doubled. So the initial temperature T1 is, we'll define it as T1. And the new temperature T2 is going to be double that, or twice T1. We're going to plug these into our equation. P1 V1 over T1 is equal to P2 V2 over T2. But before we do that, we need to solve this equation for V2, isolate the variable. We do that by multiplying each side by T2 over P2. P2 and T2 cancel out on the right-hand side, and our equation becomes V2 equals P1 V1 T2 over P2 T1. Plugging in our values, P1 is P1, V1 is equal to 8.40 liters, and T2 is equal to 2T1. All over P2, which is 1/2 P1, all over T1, which is T1. Notice that P1 cancels out, as does T1. So our equation becomes 8.40 liters times 2 divided by 1/2, which is 33.6 liters. The individual gas laws can be derived from the combined gas law. Boyle's law, Charles's law, and Gay-Lussac's law all can be derived from the combined gas law. So we're going to show you how in the next sample problem. Helium in a sealed syringe is compressed to a volume of 13 liters. Its original volume was 21 liters at 542 torr. Find the new pressure in torr. So we want P2. To figure out our given, it would look like 13 liters is our initial volume if we're not reading it carefully. It says helium in a sealed syringe is compressed to a volume of 13 liters. Its original volume was 21 liters. So that makes 13 liters our V2 and 21 liters our V1. And the original volume was 21 liters at 542 torr. So 542 is P1. Using our combined gas law, you notice there's something missing. We're given P, we're given V, we're not given T. So when T is not given, or when it says temperature is held constant, we can eliminate that from the equation because what they're saying is that the initial temperature and the final temperature are the same. So our equation becomes, our combined gas law equation becomes Boyle's law. P1V1 equals P2V2. We want to find the new pressure, so we're going to divide each side by V2, and we get P2 is equal to P1V1 over V2. P1 is 542 torr, V1 is 21 liters, all over V2, which is 13 liters, and we get a new pressure of 880 torr. Another sample problem. A sample of oxygen occupies a volume of 150 liters at 89.0 degrees Celsius. What will be the volume of oxygen when the temperature drops to 0 degrees Celsius? So we want a new volume of oxygen, that's going to be V2. We're given an initial volume of 150 liters and an initial temperature T1 of 89.0 degrees Celsius and a final temperature T2 of 0 degrees Celsius. Before we move on, we have to do some conversions because we have degrees Celsius and we need Kelvin. 89 degrees Celsius plus 273.15 is 362.15 Kelvin, and 0 degrees Celsius, we add to it 273.15 and we get 273.15 Kelvin. Now we can use the combined gas law. P1V1 over T1 is equal to P2V2 over T2. Notice what's missing though, pressure. So when pressure is not mentioned in the problem, or they say that pressure is held constant, we can eliminate it from the equation. So our equation becomes Charles's law, V1 over T1 is equal to V2 over T2. Solving for V2, V2 is equal to V1 T2 over T1. V1 is 150 liters, T2 is 273.15 Kelvin, all over T1, which is 362.15 Kelvin, and our new volume is 113 liters. I hope you enjoyed this video. To get more chemistry videos and practice problems, help from our online chemistry community, and the chemistry question of the day delivered to your inbox, sign up at chemin10.com. Membership is free and we'd love to have you. This is Melanie Fine of Chemin10.